Let's do the indefinite integration of this algebraic expression x cube plus 5x square minus 4 divided by x square. Okay, so as I had told you in some previous video, I don't know exactly which video, but I had told you to simplify the expression until and unless you are not being able to use directly few formula, right? I mean the formula that you have learned. So we need to simplify in a such a way that the condition will come where we can easily apply our formula to find the integration. All right, so what I can do here, I can just divide by this x squared to this term, and this term individually. So I will get x cube over x square plus 5x square over x square minus 4 over x square. Okay, now I can cancel this x square with this 3 because there are 3x and there is only 2, so 1x is left here. All right, and similarly here x square being cancelling. All right, plus 5, and it's as it is. I can't do anything here. Okay, now I'm going to separate the terms one by one. Okay, now we cancelled, we simplified, and it looks like I can now use here some formula. So now this dx will multiply this x, this 5, and this 4 over x squared. So I'll get 3 individual terms, and that will be x times dx plus 5. Always put that constant outside. All right, simply dx, it's coefficient constant. So again, this is 4 as a coefficient of 1 over x squared, so it is 4, and this is 1 over x squared. See, it's 4 over x squared, so I can write that 4 times 1 over x squared, that is 4 times x to the power minus 2. So I'm just writing x to the power minus 2 dx, and everywhere the same formula is going to be used. That is, yes, x to the power n dx is equals to x to the power n plus 1 divided by n plus 1 plus some constant. So now it's going to be now x to the power 1, and there is nothing, and I already told you like integration of dx is simply x. All right, because x to the power 0 dx it is, and that's x to the power 0 plus 1 divided by 0 plus 1 plus some constant. That's going to be x plus constant. So that's it. All right, so it's now x to the power, now see here it's 1, so it will be 1 plus 1 divided by 1 plus 1 plus constant 1, and now this guy will be plus 5x plus constant 2 minus 4 x to the power minus 2, so it will be x to the power minus 2 plus 1 minus 2 plus 1 and plus constant 3. Okay, and now it's going to be x square over 2 plus 5x minus here, it's going to be x to the power minus 2 plus 1, that's minus also here, see it's 4, and it's going to be minus, because minus 2 plus 1, that's minus, and x to the power minus 1. So x to the power minus 1, rather writing that, I can write that as a 1 over x plus c3. Did you get that? It's minus 2 plus 1, so it's going to be x to the power minus 1, and again you can write x to the power minus 1 as a 1 over x. And then finally x square, what about the other constant? Now c1 and c2, let's say it is c2 c1, and now x square over 2 plus 5x, and this is, you know, this 4 times minus 1 by x, so minus will multiply this minus, you will get plus 4 over x, and again this 4 will multiply this c3, so 4 times c3 plus c2 plus c1, and now these all guys are just a constant, just some arbitrary constant. So together for those all boys, I'm just writing x square over 2 plus 5x plus 4 by x plus a big constant. All right, and that's it. That's our solution. So what we learned from here, that always whenever you get any complex looking function, then you need to simplify it in such a way that after simplification you should be able to insert your formula. You should be able to use your formula.